must unlearn what you have learned.
Hello and welcome to Saturday's edition of Cracking the Cryptic, the YouTube channel where we try and create a little bit of order out of chaos and impose some structure on the universe by solving seemingly intractable problems. And on screen we have a puzzle I've been meaning to try on the channel for quite some time, but I've sort of chickened out of actually, because I know this is going to be a long video, and to actually leave myself enough time where I'm unlikely to be interrupted, well, it doesn't come along very often, but I am going to try and solve this puzzle for you today. This is by Nylimb, and it was published about a month ago on Logic Masters Germany. Since when, I've been asked to solve this puzzle many times by some very good solvers. Some people who've solved it, who say it's an exceptional puzzle, and some people who haven't solved it but have noticed that it has a 99% rating on Logic Masters Germany, which means it's an exceptionally good puzzle. Now, you're probably wondering what the rules are. Well, I'm going to tell you. Let's read them out together here. So, there we go. You can see the details here. 4 stars out of 5, which gives me a little bit of hope. 99% rating, only solved 21 times. And by Nylimb, who I think has featured on the channel once before, but not with a puzzle reputedly this difficult. So let's read the rules. This is a variant of Sandwich Sudoku in which some cells contain 2-digit numbers. Great. Fill the grid with 1-digit and 2-digit numbers so that every row, column and 3x3 box contains each of the 10 digits from 0 to 9 exactly once. 8 cells containing 1-digit numbers, and the other cell contains a 2-digit number from 10 to 98. Okay. A number next to a row or column gives the sum of all numbers between the largest and smallest numbers in that row or column. Blah, 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 blah. For example, if a row contains 4, 1, 5, 8, 2, 7, 60, 3, and 9, then the largest number is 60 and the smallest is 1. Yes, I can see that. And the sandwich sum would be 5 plus 8 plus 2 plus 7. I understand that too. Note that you could reverse the digits of any 2-digit number in the grid if it doesn't end with 0 without changing the sandwich sums. So for this puzzle, and especially for the solution code, oh, don't worry about the solution code, that's if you want to type the solution code into Logic Masters Germany, which we don't want to do. There's an additional rule to avoid such ambiguity. In every 2-digit number, the 10's digit is larger than the 1's digit, so 73 can occur, but 37 cannot. Right, okay, well I've obviously read these rules before, and in that context, although this is a live solve, I have not solved this puzzle before, I have thought about this puzzle. I've thought about it a bit over the weeks to try and sort of frame in my head and relearn and reprogram my neural network in such a way that I might be able to solve this in some way efficiently so that it's video worthy. I remember I used to watch a YouTube channel by a guy called Fleb, who I don't think makes videos anymore, but he built up over a number of videos harder and harder Rubik's Cubes to try and teach his brain how to solve the sort of most difficult Rubik's Cube. And with this puzzle, that's what I think the prior forethought might help me to do, because in thinking about the puzzle and framing it in my mind, I've noticed many things that might come in handy, and I'm going to share them with you before I start the solve. Now, the first obvious point that comes to mind when we think about the rule set here is that the 2-digit number in every row and every column has to be a crust of the sandwich, because axiomatically the 2-digit number will be the biggest number. Now the smallest number, the other side of the sandwich, is more ambiguous. That's because it could be 0. If the 0 appears on its own, i.e. not part of the 2-digit cell, then 0 is always the lower bound of the sandwich. But if the 0 is in the 2-digit cell, then the lower bound could be a 1 or it could be a 2. Now it could be a 1, well it will be a 1 if any number other than 1 appears in the 2-digit cell with the 0, but otherwise if the 1 accompanies the 0, so we have a 10 in one cell, then the 2 will bound the sandwich. And that feels to me like it's helpful because I now know that in every row and column I have to pay very special attention to the 0s, the 1s and the 2s and the location of the 2-digit number. And that is how I'm going to try and solve the puzzle. Now, do have a go at this. I'd allow yourself some time and click on the link under the video. That will take you to this web page. It's not our software today because in order to put in 2-digit numbers into cells, we have to use the Pemper software. So check that out. And yeah, as I say, this is going to be very interesting. I'm looking forward to this. Let's get cracking. Now, right, this 42 clue is absolutely massive. This was another bit of thinking I did about this. Let's think about what is the maximum size of a sandwich that we could create in a puzzle with this rule set. So obviously that's going to be, let's do some highlighting. Let's imagine we manage to put 7 cells in the sandwich and we make all of these 7 cells the biggest numbers we can. So we're going to make them 9, 8, 7, 6, 5, 4 and 3. What does that add up to? Well, that adds up to 42. So this row here is a maximum row, and the extremities of this row, the sandwich cells, have to include the numbers 0, 1 and 2 in some permutation, but we don't know what that permutation looks like. But what I think I'm going to do is I'm going to try and label cells that are not sandwich cells, that are not crusts of the sandwich, I should say. So I'm going to label these as green, just to see if we can use the similar technique that I'd use on standard Sandwich Sudoku. Yeah, okay, and the 41 clue works the same way, doesn't it? Because if we think about it, every row and column must have 3 digits sort of siphoned off and put to one side to be the crusts of the sandwich, because there's a 2-digit number and then there's the other side of the sandwich. So there's always 3 digits that are not and cannot be part of the sandwich total. Now, if we know that every row and column of a Sudoku, well, let me put that a different way in the context of this puzzle. If we know that the digits 1 to 9 sum up to 45, and I have to remove 2 digits, because I can remove the 0, but I have to remove 2 digits from the numbers 1 to 9 as well, then I can't, there's no way I can remove more than 2 and create the number 41 in the sandwich. It's impossible. So actually this column as well has to have crusts at the edges, and those crusts will obviously include a 0, a 1 and a 3, but again no clue as to how they'll be disposed. Okay, let's think about the 40 clue. Now, the problem with the 40 clue is that maybe it's possible to have a cell outside the sandwich with the 40 clue. Oh, no, it's not. No, it's not, because if we know the sandwich clue contains, or the sandwich crusts contain 3 cells, if I postulate for a moment that there is a 4th cell that is not in the sandwich, then there would have to be 4 digits between 0 and 9 that I take out of the sum, the 45 sum. So what could those digits be? Well, the lowest digits I could take out would be 0, 1, 2 and 3. That adds up to 6. 6 minus 45, or 45 minus 6, is 39. That is too small. So actually this also has crusts at the edge. Now that might be useful, and is useful, because now we might be getting somewhere, because one of these columns, well, let's look at the 42 clue. Either column 1 or column 9 has a 2-digit number in it. Now, whichever one that is, there can't be another 2-digit number in that column thereafter. So in fact, the 2-digit numbers in these rows form an X-wing on 2-digit numbers. How mad is that? So let me show you what I mean. If that's a 2-digit number, this will be a 2-digit number. If, on the other hand, this is the 2-digit number, that will be a 2-digit number. Now, does that matter? Well, I'm sure it does matter, but can I use it to deduce anything? Yeah. This clue, this one clue as well, that is suspicious, isn't it? How is that? So that a one clue means the 1 is inside the sandwich. So the 0 cannot be in the 2-digit cell. So this column is going to have a 0, then a 1, or reversed, a 0 down here and then a 1, and then the 2-digit number. And we know the 2-digit number is in one of these two positions. I'm going to put some options in. Let's look at this square. So this square, we know that the sandwich crust here is made of the digits 0, 1 or 2. Well, it can't be 1. Or can it? No, it can't be 1. Right, this is really difficult to actually visualize, but if this is a 1 here, we know this will be a 2-digit cell, and we know this will be a 2-digit cell, and now we've broken this column, because there will have to be a digit between the 2-digit cell and this 1. So that's not going to work. This cannot be a 1. And therefore, the 1 in this column is not in this cell. Full stop. So this cell has to be it could be a 0, or a 2, or a 20. This is completely mad. So the 1 is over here, and it could be on its own, it could be a 10, or it could be a 21. Right, so but in this column the 0 bounds the sandwich for certain, so 20 is not possible, because if we put 20 into this square, let's look at it. If we put 20 and then try and put a 1 here, for example, how do we make this the other crust of the sandwich? Whatever digit I put in here is greater than the number 1. So actually, if this was the configuration, this clue should have been a 0, and it's not. So this is not right. This cannot be a 2-digit sum. Sorry, that was a bit slow. So if this is not a 2-digit sum, this is the 2-digit sum. So this can't be a 1, which means, let's make that red. That means this is the other 2-digit sum. And was about to say this can't be a 2, but I'm not actually sure that's right. If this is a 2, you see the 0, could the 0 be down here now? So this is, the 1 would be here, this would be the 0, and this would be the 2-digit sum. Oh, no. This doesn't work. And it doesn't work because of the 40 clue, of course. Because now, what is the minimum I can put into this square? Well, I could put the numbers 3 and 4 into this square. But the moment I do that, I can't put 40 inside the sandwich here. Because I've got 3 and 4 outside the sandwich. We know that the total for the row is 45. If I remove 7 from it, the maximum I could put inside the sandwich is 38. So this is not right. This is not right. This is a 0. And that's going to be a digit in the grid. What's more, that's a 0. So this, yeah, this is the 1. This has to be the 2-digit sum. And we've got to be careful with that because does that have to be 32 now? And this be a 0? That's what it feels to me like. Let's just check. Now if this is 0, of course, this is 21 because we know we need to remove exactly 3 from the sandwich. We know that the 10's digit is higher than the 1's digit, so 21 rather than 12. The 3 clue now. So to have a 3 inside the sandwich when we've removed 2 and 1 from the possibilities means that 3 is on its own and 0 bounds the sandwich. So yeah, you can see there's just simply no way we can do this like this, because this square now has to be at least a 4 and this square has to be at least 23, and then I've removed far too much from the 40 total. So actually this has to be 3, this has to be 0, therefore this has to be digits totaling 5 without using 1, which means it's 32. And we're nearly finished. After 17 minutes. Okay, right, come on. I'm actually quite proud I've got this far. So now there's a 3 in one of these 3 squares. Let's notate that in case it becomes useful. I'll tell you what I'm going to do. I'm going to do some colouring. Because if I can locate all of these 2-digit cells, then we are going to be cooking with gas, aren't we? So there can't be any 2-digit cells in any of these positions now because of what we've got already. So which is the natural? This can't include a 0 now, but it could include 1, 3, 31. This down here could be still be the 2-digit sum as well. Yeah, the 35 clue. What is the minimum number of cells I could make 35 with? It would be 5. 5, 6, 7, 8 and 9 sum to 35. So the 2-digit sum in this row cannot go in any of these 3 squares, because if it does, I haven't got 5. You know, if I put one here, 1, 2, 3, 4, 5, they would all have to be part of the sandwich and the crust would be outside the grid. So these cells are not in the sandwich. So the crust is in one of these 2 positions. 1, 2, 3, 4, 5. So if it was here, the 1 would have to bound. No, it can't be there. It can't be there. Because if it's here, in order for 1 to bound the sandwich, which it would have to, because I need 5 cells inside the sandwich to get to 35, this square would have to contain a 0. This would have to be a 2-digit number that contains a 0, and it can't contain a 0. So I think this square has to be the 2-digit cell. Now, that means we can label all of these green. 1, 2, 3, 4, 5. So this square has to bound the sandwich and has to include a 0. Look at that. That is very nice. 0. Oh, not 1, 0. So this contains the digits 2 and 4, so that's got to be 42 in order to give us 5, 6, 7, 8 and 9 inside the sandwich. So I'm also going to label which clues I've used, to be honest. I've basically used this clue. I've used this clue in the sense it can give me no more information. This clue I've used. This clue I've used. This clue I've used. I think that's all. Still haven't done the 41 clue. But I've just noticed that this column has a 0 on its own. So we know 0 is a crust of the sandwich. 25 is a relatively large number. Even though I could put 9 in the sandwich, 9, 8, 7 only gets me to 24. So that this has a 4-cell sum at least. Therefore, where does the 2-digit sum go here? It can't go here. It can't go here. It's got to be 4 digits. It has to be. So it has to be here, I think. Now, why is that important? Well, that's important because now the 41 must have its 2-digit cell there. And all of a sudden, we are starting to impose some structure on this seemingly impossible problem. Now, can we go further? 5 clue. That's very restricted now because of this 42 clue. Because that means I can't make 5 with a 2-cell sandwich because, well, 2, 3 and 1, 4 are impossible. So this has a 1-cell it has a 1-cell sandwich, and look at this again. If we try and go downwards, what digit has to be here in order for this to be the end of the sandwich? It's going to have to be a 0. Because if it's anything else, if we try a 1 there, then 0 would be the lowest number in this column, and the 0 would not be, it's not bounding the 5. So we actually know that this is not 5. The 5 must be here, and the 0 must be here. And so there's a 0 in the top row of the grid. Now that's interesting as well, because that 0 can't be in a 2-digit cell. So wherever this 0 is, it's going to bound its sandwich in the column. Now look here as well, we've got 2s and 0s. So 0 is somewhere along here, 2 is somewhere along here. But of course, there's also a 2-cell sum along here as well. So there are going to be 4 digits in these 3 cells. This is very hard. I feel like all the intuition I have about solving Sudoku has just been sort of shot in the head. And so how do we do the next part of this? The 23 clue, that must be at least a 3-cell sandwich, 9, 8 and 6. But we know that So can this square be the 2-digit cell in this row? That would I don't think it can. And the reason is that that would place the boundary either here or here. But if you look at both these columns, you can't put a valid cell boundary because 0, 1, 2 and 3, 0, 1, 2 and 3. And we talked earlier on about how the boundary has to be, the lower boundary has to be a 0, 1 or a 2. So I think this square is green. It's a bit annoying actually, we don't know what this column is, so we can't use it to make more progress there. 9 here. Well, 9, the problem with 9 is it could be a 2, 3, 4, or it could be include a 1 even. I don't think we get anything from this 9. In the 7 column, again, I'm not sure how to do that. Feel like I'm missing something here. Right, here's some logic. In this 19 row, we know that the 2-digit sum is somewhere along here, one of these 3, and we know the 0 is in one of these 3. So those 2 cells must coincide, otherwise we're going to have too small a sandwich. But if I put the 0 here on its own and put the 2-digit cell here, there's obviously only one cell between them, and one cell can't add up to 19. So in this little block of 3 cells, we know that the 2-digit cell and the 0 cell interact. We also know, moreover, that the 2 and the 3 are in here. And either of those is going to be too close to bound the 19 sandwich. So actually we're looking for a 1. A 1 is going to be the boundary of the sandwich in this row. There can't be a 1 over here, so the 1 must be over here. And look, the 1 can't be in this column. That's it. That's it. The 1 has to be here. The 1 has to be here because 19 is at least a 3-cell sandwich. 1, 2, 3, and that's the 2-digit sum. Whoa. So this is red. This is then. Let's put some greens in as well. These are all greens. This square here is a number 1. The 0 is definitely in this cell as well, so we can get rid of those zeros. And yeah, we can go further. The 19 sum, look, this square's got to be either 20 or 30. Now, why do I say that? Well, because if it's not, if this was some other number with the 0, if it was 50, we know the 2 and the 3 would be in these 2 squares. They only add up to 5. This square would have to be 14. It can't be. So we've got to use the 2 or the 3 in this cell as well. And then if it's a 2 in here, we're going to have an 8 and a 9 in some order. If it's a 3, we're going to have 9 and 7. So there's definitely a 9 in one of those 3 squares. This square can't be a 0 now because we know the 0 is in one of those squares. It seems very unlikely that this square could be a 2-digit sum. Although maybe it could. No, hang on, let's think about that. If this square is a 2-digit sum, we know it can't include a 0. So we know the 0 is going to be the boundary of the 11th clue if this square is a 2-digit sum. Where can the 0 go? Well, because we know there's a 0 in here, the 0 could go here. That would be the earliest we could put the 0. And that can't work, because if this is a 0, how do we do this 23 clue now? We have to put a 2-digit sum somewhere along here to bound the sandwich, and 23 is a big number, so there's nowhere to put it. It would have to come over here where there's already a 2-digit number. So I don't think this square can possibly be a 2-digit number, and if that can't be a 2-digit number, where does the 2-digit number go in this box? It must be there. This square is green, this is green. Oh, and I've put the 2-digit number in this block, so 1, 2, 3, 4, 5, 6. I've got 7 2-digit numbers sorted out. I've got 2 more, and look, if we look at the arrangement here, none of these clues is a 0. Well, not that it could ever be, but the 2-digit number must be offset. Well, it can't be here. This can't be a 2-digit number, because if it is, how does this 7 clue ever get filled? We know that the boundary, the other boundary, the one that's not the 2-digit cell, has to be a 0, 1 or a 2. Well, look, we've got 0, 1 and 2 in this box already, so the 7 clue would have to end somewhere up there, which it can't. So this is just absolutely impossible. This is the arrangement of 2-digit numbers, and I am somewhat startled to find that we've got there 31 minutes. I knew it was going to be a long video. Now, so let's look at this column first. Where does the 7 clue get bounded? Well, it can't go up, because we've already looked at that. I mean, if we, even if we try and make the 7 clue longer and make it 1, 2, and 4, none of those digits can go into this string. So the 7's got to be a single cell 7, and it's got to go down. This is a 7. How do I do 7? This is the boundary. Now look, we know there's a 0 in one of these 2 clues. Oh, whoa, this is getting complicated again. And there's a 1. Oh, and there's a 2. Oh, good grief. So I don't know how to resolve it. I just know that there's a 0, 1, 2 here, 0, 1, 2 here in some order. This is the combination. I just can't quite tell how we resolve the ordering. Now let's think about that. 0, 1, 2. So the 23 clue now. Oh, I tell you what's interesting. Look, this 0 is interesting and this 0 is interesting, because we know there's a 0 on one boundary of this 41 clue, and therefore we actually know it must be this. This is a single cell boundary, and as this can't be a 0, this has to include a 0, so this is a 0. So this has to be the number 31. Sorry if you guys have spotted that ages ago. Now this can't be a 0 over here. So the 0 is in the 2-digit clue. Oh, lordy. The 0 is in the 2-digit clue. Well, the problem is that 1 could be as well. It could be 10, it could be 20. In fact, in fact, that's a better way of looking at this. It is 10 or 20. I just don't know which one it is. And this is 1 or 2. And whichever one of this is included, the 1 or the 2 is going to be the boundary over here. So is there a way of getting a handle on which one of those is correct? There probably is. I'm just not quite seeing how to do it. Ah, no, hang on. We can do... Hang on. Let's look at the 11 clue again. This is the 2-digit cell. So if this is a 0, all of these cells have to be in the sandwich. That's not possible. So the 0 moves over to here. That's for sure. That is a 0. I'm just wondering whether... Yeah, now look. Now there is a 0 in this sandwich clue as well. From the zeros and normal Sudoku, this cell has to contain a 0. So this cell is... I don't know what the first digit is, but it's... Oh, it's X0. Which means the boundary here... Ah, yes, okay, so the boundary here is a 1 or a 2, because it can't be a 0, which means it can't be this square, because there's already a 1 and a 2 in this column. So this 9 clue comes this way. Might help me to actually... So it comes at least 1 square. The 23 clue must come this way, and that comes at least 3 squares. The 19 clue we know is those 3 squares. These 2 clues I'm not labelling, so I'm just going to clutter things up. These 2 squares have got to add up to 9, look. This one we don't know about. Let's look at the columns. So, yeah, in this column we've got that sum adding to 25. And we've got this 11 as well. Oh. Ah, yeah, but this 11 clue we can do something with, I think. Because we know this square contains the 0. So we're looking for a boundary in the form of a 1 or a 2. Now, there could be a 1 here. That is possible. There can't be a 2. Here, there can't be a 1 or a 2. So this cannot be the boundary. Here, there can't be a 1 or a 2. So this cannot be the boundary. And if we go further away than this, we've got too many cells in the sandwich. So all of that means, I think, that this square is a 1. Let's colour it in green again, otherwise it's going to look a bit strange. Now, this being a 1, that's remarkably unhelpful. So these two squares here sum to 11. Okay. Ah, wow. Well, that's sort of, I suppose that's useful. I've used this clue now. I've used this clue, but I can't make out the difference between the 1s and the 2s. Use the 5s. The 19 clue, we sort of have a rough idea of what that looks like. Oh, I didn't mean to do that. Whatever I did there, I didn't mean to do it. That's a red square. I'm wondering about the 17 clue now, because 17 has got to be at least 2 cells coming from here. Yes, here we go. Here's a breakthrough. So, if this 17 clue comes downwards, and this is the boundary, these 2 squares would have to be 8 and 9. But look, this 9 clue is coming this way. So even if this is an 8, even if we try 8 here, we've now broken this total, because this would then have to be a 1 in order to add to 9. And now how does this get bounded? I can only put a 2 here, but if I put a 2 here, the 1 should have been the boundary and wasn't. So that doesn't work. This cannot come downwards. So this has to go upwards. And looking at what's in here, we know there's a 0 in here, so the 1 is going to bound this on the top side. And there's a 1 here and a 1 here. This square is a 1. Okay, now, does that get me where I need to be? So this, let's do some shading again. These 3 squares get shaded. Ah, yeah, it does. It gets me closer to where I want to be. You can see we have a 1 here and a 1 here. Now, can this square be a 1? Now, if this square is a 1, this will be 20. And these will be the boundaries, but we need to put 23 into this 1 square. That's not possible. If this square is a 1, again, these 2 squares then form the boundaries, and that's not going to work. So the 1, I think, has to move right down to the bottom there, which resolves that this is a 2 and this is a 10 after all that. Okay, now is that in and of itself enough to get me moving again? Yes, look, 1s now. By normal Sudoku, if there's such a thing within the grid of this complexity, we have a 1 here, a 1 here, a 1 here, and a 1 here. So that square's got to be a 1. And that is massive. Look, we've got 25 total here. That now includes a 1. So these 3 squares have got to sum up to 24, so they have to be 7, 8, and 9. Ooh, now. 7, 8, 9, 7, 8, 9, 7, 8, 9. Oh, now that's huge for the 23 clue. Where is the boundary? We know one boundary is here. So the other and it contains a 0 or 1. So we need a 2 to form the other boundary. Can't be here. Can't be here. It's got to be here. That has to be a 2. That means these 3 squares sum up to 6, 8, 9 to make 23. So that square has to be a 7. Let's correct these 2. That can only be 8, 9 now. That can only be 8, 9. This has to be 6, 8, 9. This 1 forms the boundary for the 9 clue as well now, because we know this contains a 0. So these 3 squares have got to sum up to 9 without using 1. So they've got to be 2, 3, and 4. There's a 2 and a 3 in column 3 already. Oh, we are. I think I might be able to do this puzzle. This is a 4. This is a 2 or a 3. This is a 2 or a 3. That square can only be a 5 with the 0 now, because it can't be 1, 2, 3, and 4. It can't be 6, 7, 8, or 9. This square has to contain a 5 and a 0. It has to be 50. 50. Now, yes, 19 clue, look. 8, 9 here now. So if this 19 is made up of 2, 8, 9 in here, this cell would have no value. So it can't be. There must be a 3 inside the sandwich. So if there's a 3 inside the sandwich, the 3 is not in the 2-digit cell. So this has to be 20. This is 379 now. Now, can we... Well, that's got to be a 9 because it sees a 7 and a 3 in various places. So this is 3 and 7. It's probably, I'm sure you guys are spotting how to resolve that. I can't quite see, but we know that this has got to be 3 and 7. This has got to be 3 and 7. Oh, one way I could resolve it is using the 11 clue, actually. Look, if this is a 7, this would have to be a 4, and it can't be. So this is a 3, this is an 8, this is a 7. So these two clues now have to be just 6 and 9. This 9 resolves the 9, 8 over on this side. So now I can grey in more cells. That will make me feel better. Look, I've done this clue now. Well, I've all but done it. I haven't done the boundary, but I've used the information inherent in the clue. Same here. I haven't used this one yet. Have used this one. I've used that one. I've used that one. Oh, I haven't used this one yet. I have used this one. I have used this one. And I have used this one. This 2... just seen, sees the 2 and the 3 here. So we can do one more number. That's going to be a 3, that's a 2. So there's now a 2 in one of those two squares. Ah, well the 2 can't be here, because if it was, this would have to be a 7 to make the 9 clue work. And that can't be a 7, there's a 7 down there. So the 2 goes right to the top. That means there's a 2 in this cell by normal Sudoku. These two squares have got to be 4 and 7 to complete this box. So I'm going to label that. So what are the options now for this 9 clue? It can't be, look, it can't include a 5, so it can't be 4, 5. It can't be 2, 7. It can't be 1, 8. This has to be 3, 6. There's a 3 here, so we get that one as well. This is a 3. This is a 6. So the 3 is in one of those two squares. But we don't really know how to resolve that. It's quite amazing that this is going to solve from here. We've used this clue now. So we've only got the 17 clue to disambiguate everything. What can this cell contain? It can't contain 0, 1, 2. It could be a 3. It can't be a 4. It could be a 5, I think. And it could be a 6. Okay, so we still don't know what this square is. Oh, yes, we do. It's got 3 here. Oh, whoops. I didn't mean to do that. There's a 3 in these two positions. So this square here is a 3. Let me get that back to being red. And I need to put a 3 in here. Oh, no, I don't put a 3 in there. Actually, it's a 2-digit number, of course. So it's going to be 53 or 63. I don't know. Could be either. Oh, let's have a look at this one. Look, I've not got no, I haven't got a 3 in this row. That's got to be a 3. So that means this is a 4 or a 5. That can't be a 4 because of this 4. So that's a 4 over there. Now there's a 4 in one of these two squares. I can't see how to resolve it. There's 5s, look. That means this square is a 5. So now we're left with 6, 8 and 9 down here. Bother! 6, 8 and 9 are all possible. Let's have a look at this row. So this is 4, 5 and 6 that we're missing here. That's got to be a 6. So this, that's got to be a 5. That's a 4. That's a 5. Okay, maybe. That's a 4 now. 4 here, and this 4. So that's a 4. This contains a 4 and something else, which we don't know. So is it the 17 clue? Is that what I have to look to now to sort everything out? Let's have a look at it. So if there is a 9 in the sum, then the other cells, 2 cells, would add up to 8. That's not possible. We've already got 1, 2 and 3 in the column already. So 9 is not in this sum. If 8 is in the sum, it would have to be 4, 5, 8. Now that might be possible. If 8 is not in the sum, we'd have to use 7. So that would have to be 4, 6, 7. That would make this the 7. Oh no, 4, 6, 7 doesn't work, so we've got a 4, 7 here. And we can't go less than 7, otherwise we can't get to the total. So actually this is 4, 5, 8. This was where we were meant to look. So this is 4, 5, 8. The 4 must be here. The 5 must be here. The 8 must be here. Now that fixes the 4 and the 7 at the bottom. This square's got to be a 6 or a 9 as well. 5 must be here, just by normal Sudoku rules. If we look at this box, look, we've not placed 7 and 8. And there's a 7 there, yes. So 7, 8. This is an 8 now. This is a 6. This is a 9. I am only too acutely aware of how easy it would be to make a mistake with this. Right, that's a 6, I think. I think that's the missing digit from this row and box. These 2 squares are 8 and 9. There's an 8 placing 8, 9. These 2 squares are 6 and 7. 6 here, so this is 6, this is 7. These 2 squares are 8 and 9. Oh, I've still not done this one. So this column needs a 6 and a 3. This has to be 63. 8 and 9 here. I don't know the order. This 6 and this 6 means that that's a 6, which means that one's the 9. So this one should be the 9. So this one should be the 9. 9's in one of those 2 squares. 2. This has got to be a 3, I think. So that means this square needs to be 5. So this square is 54? I think that's right. It does look like it's not clashing. Now, 7 and 8 over here, that's doable. That places this one as a 6. Again, it's working. This is a 6 now because of the 6 here. We need 8 and 9, the 9 there. 8, 9, 9, 8. 53 minutes. That's a good result. I'm very happy with that. I can't see a mistake. You guys tell me, or please, well, I'm really hoping you don't tell me. That is a tour de force. Nylimb, I did enjoy it. I feel like, as I say, my head's been put through a mangle, and I've had to unlearn what I ever learned before. But yeah, that's what we're here to do. I loved it. Thank you very much indeed for watching, and we'll be back later on with another edition of Cracking the Cryptic.
You must unlearn what you have learned.